Anyway, if you watch closely here on the silver metal, I know I just put my phone in the way, but you'll notice the copper metal doesn't look very coppery anymore. It's begun to change color, and the reason it's changing color is because we're actually getting growths of silver crystals on the surface of the copper. And the coating is beginning to get fairly thick in some places. I'm noticing right here specifically, there's a fairly thick coating of silver already. And if you come up close, now or towards the end of the period, you can take a closer look at the crystals. I don't know that in this short of a time period we'll actually begin to notice the solution change color. I'll let it sit over the weekend. I'll put some paraffin over the top to keep it from evaporating, and we can take a look at it again on Monday. And if you take a look at it on Monday, you'll see that there's definitely a color change to the solution. These copper solutions, it turns out, all tend to be a bluish color like this. And so you actually begin to see the copper solution turn blue. It won't turn that deep of a blue. It'll be very pale because there's not that much copper there, but you will definitely be able to notice a blue tinge to it. Oh, there's a little bit right back here in the back, I can see now when I'm looking at it from above, where there is copper metal that's sticking up out of the back. And so you can really see a good, real clear contrast between the silver crystals that are forming on the surface and the copper metal that's up at the top. The request that I had from YouTube happened to be for a iron wire, and so I'm going to stick iron metal in there one of the other periods. I haven't decided what my third metal is going to be yet. I can do lead, but lead's pretty slow. I could do magnesium, but magnesium's awfully fast. I gotta take a look and see if I have some kind of another good in-between metal. But this here is the first of our replacement reactions, or the first of our chemical reactions, and it's a single replacement. It's called a single replacement because we have something alone here, and the one thing replaces something else. And so we have the copper here taking the place of the silver, and the silver coming over here. What that actually means is happening is the copper is losing its electrons to the silver is gaining electrons. And so they're actually trading the amount of electrons they have, and that's something that we'll get into later in the year called a redox reaction. Down here, it's getting super shiny. You can begin to see really pretty silver crystals growing. Just like, I'm gonna move this going.
Oh, that's cool.
And so, the real good shiny silver that I notice is down here, and up here is the bare copper wire.
That looks really cool.
Oh, I see some good silver on your side as well now. It looks like that middle coil is getting the best.
It's really shiny.
Yeah, and you guys get the prettiest of them, I think. But the iron is, I've seen the reaction before. I've not personally done it, but the iron reaction is a little bit
Look at the top.
uglier.
You can see where it says dull copper.
And you can also see how thick that coating is getting to, because that copper wire is real thin. And you can see that there's this coating of silver crystals. It's just growing bigger and bigger.
Over the weekend, will the copper completely go away?
And not 100%. I actually never cleaned up last year's. And so this is what's left over from last year when I did it.
Yeah.
And the water all evaporated away. But there's plenty of copper left in there, but there's also lots of silver. And the silver is decently expensive. I mean, that solution, this 1 liter bottle cost me about $50.
Oh, wow.
So there is a way to recover this. Basically, you react them both with nitric acid, and then you precipitate out the copper, and then you can leave the silver in solution. You can recreate this. You can never recreate it as pure as it was here, but I can recreate this, which is the goal. And it's also part of why the bottle is as gross as it is. It's because it's been recreated a lot of times and it's no longer as pure. No, the copper wire doesn't go away completely. There's not enough silver there. And that's the, I don't know, I guess the misleading thing about this is that even though they're replacing one another, every chemical reaction has
That's
what's
really
called a limiting reactant, a chemical you run out of, and in this particular case, this is the chemical we run out of first. In part because it takes twice as much of it in the reaction, and in part just because there's not that much silver in here, really. Why it's so expensive. I have way too much copper in there, and so then we don't run out of copper.
It's like a rustic.
If we had instead done like a BB, I mean, you don't get as, it doesn't look as awesome, but a single copper BB or a single copper pellet would give you, you could probably react away all the copper with the silver and have the copper be the thing you run out of, and at that point you would be done. But anyway, have a good weekend. Be sure you study for Monday's test. Hello.
Hi. Hi.
In just a second on this one. I'm going to stop at about 12 minutes here. I've got 30 seconds left. This is a sneak peek at today's Kim demo for you, by the way. Although I'm planning on doing a slightly different version each period, if things go well. About 15 seconds here.